Hello dear students, welcome to Royal Palace PU College online classes. Dear students, in this particular session, we shall start with the exercise number 3.2. Already we had continued some of the problems in your exercise number 3.2 in the last class, okay, that were all related over, okay, that is the science of trigonometric functions. So now today in this class we shall learn about that is find the value for all this sine of 275 or it is 765, all these values we shall discuss, and these all problems are related over trigonometric functions of allied angles that we have discussed in the previous two sessions. Now, so these are all the problems related to trigonometric functions of allied angles, and it may be asked in the question paper for 1 marks or either 2 marks, an important point of view here. Okay, now let us begin our discussion here. So now in the previous class already we had seen that, okay, already we had looked onto that, okay, that is trigonometric functions of allied angle, that is nothing but x, x dash, y and next y dash. It is our first quadrant, second quadrant, third quadrant and next fourth quadrant. The sign depends on AS TC rule, that is all are positive, sine and cosecant are positive, tan and cot are positive, cos and secant are positive here. Okay. Next here in this that is nothing but north and south, that is 90 and 270. Okay, 270, the value changes. Value changes. Okay, the value changes here. Value changes, and here the value remains same. Value same. Value same. It is nothing but here 180. And here it is nothing but here 2 pi 360. Okay, here the value remains same in both east and west, that is nothing but value same, value same, and here the sign depends on your ASTC rule. Now let us begin our discussion, and one more thing, this complete revolution it is nothing but 360 degrees, after that it repeats, okay, that is again it can repeat here. Now let us examine our first problem. The first problem that we shall discuss, that is the sixth example, that is sine of what we are having is that is 765 degrees. Now we know that 360, whenever it is crossing beyond the 360, just we have to take whether we can add and subtract with some standard values. What are the standard values? 80 plus or minus, then 360 plus or minus, 90 plus or minus and 270 plus or minus. In that particular standard format we have to look here. Now here we can observe that, can I write it as a sine of 2 into 360. What is the value here? Sine of 720 here, that is sine of 720. 720, okay, here what we have? 65. That means 720 plus what is the value here? 45. Sine of what we are having? 720 plus 45. Now what is the value for that? There is nothing but here sine of 2 into 360, okay, plus 45 degrees. Now in this trigonometric function of allied angles, 360 into multiples of 360, that means again it is in nothing but here, that means here the value remains same. What will happen here? That means it becomes sine only. It is plus here, plus means where it comes? Again it comes in the first quadrant. Now whether it is a multiple of 3 pi, okay, 2 pi, or it is multiple of 360, that only we have to look here. Now everything will be same here, that is sine of what we are having? 45. Now what is the value for sine of 45? The value will be nothing but here 1 by root 2. That is nothing but very simple example. Okay, dear students, these kind of problems are very simple. Only the thing we have to look here is this should be in the standard format, that is 360 plus or minus, 180 plus or minus, 270 plus or minus, and here this should be trigonometric values. That is what we are knowing, that is sine of 0, 0, 30, standard angles 0, 30, 45, 60, 90, okay, pi, 3 pi by 2 and 2 pi. Okay, these are all trigonometric values we are knowing. That's why we can adjust to these particular things only. Okay, dear students, now let us move on to the next one. That is the seventh in your exercise number 3.2, that is cosecant of minus of 1410 degrees. Okay. It is also a very simple example. Now here 720 means it is a multiple of 2 pi. Here also we can observe that it is nothing but here 1410. Now here what we can write here? 360, okay, 360, that is nothing but here, then here 2 into 360, what we get? 720. then 3 into 360 values, okay, 3 into 360, what is the value here? 0, then 18, okay, that is 1080 value, then 4 into 360, now what we get here? 0, 6 4s are 24 here, 4 we get, 2, 4 3s are 12, 14, 1440, that means 4 into 360 value, what is it? 1440, that we shall make use. Before going with that, cosecant of minus theta, the value will be minus cosecant theta, that is nothing but 1410, because, okay, because cosecant of minus theta value will be minus cosecant theta. Now where does it comes here? That is nothing but here cosecant of minus theta, it comes here in the fourth quadrant, minus theta also, it is nothing but minus theta, fourth quadrant. Here in the fourth quadrant only cos and secant are positive, okay, cos and secant are positive, remaining all are, okay, negative. That means cos remains cos only, and here cosecant is negative in the fourth quadrant. One thing. Next thing is, okay, this 1440, as I said, that is minus cosecant of, that is I can write it as, okay, 4 into 360, okay, then here minus of what? 4 into 360 means what we had seen, that is nothing but here 1440 here, minus of what? Value is equal to 1410, that is 30. If I do it, that means 1440 minus 30, again what I will get here? 1410. In that manner we have to adjust. The similar manner also, 720 plus 45, what is the value? 765, okay. Both values should be known here, and this value also we should adjust it. So what we get here, that is minus cosecant of, that is 440, 1440, that is nothing but 4 into 360 minus 30 here. Now here that implies what? 360 minus theta it implies. 360 minus theta means again where does it comes? It comes in where it is? That is fourth quadrant. And here the value remains same, okay, that is minus of cosecant of, that is 30 degrees. Now cosecant, it is positive or negative in fourth quadrant? Cosecant is negative in the fourth quadrant. So therefore minus of minus cosecant 30 degrees, minus of minus, that is nothing but here what we get is cosecant of 30 degrees. Now what is the value for cosecant 30? The value will be 2 here, the value will be 2. That is nothing but our required result here. Very, very simple thing. Now let us move on to the next problem, that is the question number 8. Okay, question number 8, the value is tan of 19 pi divided by 3. 19 pi divided by 3. How to solve it? Very simple. Pi means the value substituted, that is 80, 180. So what we get here, that is the 19 into 180 divided by 3. What we get? 3 ones are 360. Okay. Then here 19 pi divided by 3, that is nothing but in terms of degrees what I get the value is, so the value will be 1140. Okay, 1140 values will be, it is 19 into 6 here, 1140. Now this particular value, how we require to solve it? Just now we had seen about, that is the tan of, what is the value now here? 360. Okay, we are not multiples of 360, that is 360. Okay, that in 2 into 360, that is 720. Then 3 into 360, that is nothing but 1080. And next 4 into 360, the value is 14. What we have here, that is 1440. And then 5 into 360, the value will be 1800. That means here, which one is near here for 1140? I think so the nearer will be 1080 will be nearer. So what I can write here, that is a tan of, what I can write is 10, okay, 80 plus what value is equal to 1140. That means I have to subtract here. So what we get here, that is nothing but here 20 plus 40, that is nothing but here 60 value. 1080 plus 60 equal to, okay dear students, now here that is nothing but tan of 1080 plus 60, that is nothing but 1140. So now here tan of 1080, that means what is the value here? 1080 means it is nothing but here 3 into 360 plus 60. Now where does it comes here? That is 360 plus theta, it means it is nothing but our 360 plus theta. 360 plus theta means it comes in the first quadrant. That means the value remains same, and we are knowing that 360 plus theta means that is nothing but theta only, and the theta value here is 60 degrees. Now here what is the answer? That means tan of 60 degree, that is nothing but here root 3. Okay, it is a very simple example. Now let us move on with the next problem. The next problem will be, that is a cot of minus, okay, the value is minus 15 pi by 4, okay, cot of 15 pi by 4 here. Now 15 pi by 4, if you want, you can convert into degrees here. That is 15 into 180 divided by 4, that is nothing but 15 into 180 divided by 4. Now here that is nothing but here 45, and the value will be here after converting. So 15 into 45, the value will be 675, that is nothing but cot of 675 degrees. If you want, you can make use of calculators here. Now here we can observe that 675, it is nearer to 720, but not 360 here. Remember it, it is not near to 360, it is very near to 720. That means I can write it as 720 minus of what value is equal to 675. What we have to subtract so as to get here 675, the value will be 45 degrees. Okay, if you subtract it 20 and 25, that is nothing but here 675. Now here what we get here, that is a cot of 720 means 2 into 360 minus 45, okay, minus 45 here. Now what values we are getting here, that we shall observe here. Now that is nothing but here cot of 2 pi minus, that is 360 minus theta. 360 minus theta means it comes in the fourth quadrant. Fourth quadrant, the cot is negative, and cot value remains same as it is. The value will be cot 45. Now what is the value for cot 45? The value will be 1. So what is the answer? The answer is minus 1. Okay, dear students, now let us move on with the next problem. The next problem, it is also very simple. That is nothing but here cos of minus 1710, okay, minus of 1710. Now how we have to solve it? Now cos of minus theta, what is the value for cos of minus theta? The value will be cos of 1710, because cos of minus theta is nothing but here cos theta. In which quadrant does it comes? It comes in the fourth quadrant. Fourth quadrant, cos of minus theta, cos is positive, value remains same. Next term is this cos of 1710, can I write it as 1800 minus 90 here? Why? Because this 1710 is very near to 1800, that is multiple of 360. What it is, that is nothing but here cos of 5 into 360 minus 90 degrees. That is nothing but 360 minus 90. 360 minus 90 means where does it comes? It comes in the fourth quadrant. Fourth quadrant, cos is positive. So what we get here, cos of 90 degrees. Now what is the value for cos 90? The value will be 0 here. Okay, dear students, these are nothing but our very simple examples related to our trigonometric functions of allied angles. Okay, and these are very important as per as examination point of view, may be asked for 1 marks or either for 2 marks. Okay, dear students, so before going to the next topic, that is nothing but our trigonometric functions of compound angles, please pause the video to note it down. Okay, dear students, now let us begin with one very important derivations that comes under your trigonometric functions of compound angles, and it is a very important for how many marks? That is 6 marks. Fixed question in the examination, this question is always fixed for your question number 49A. Okay, 49A, that is nothing but here 6 marks derivations here. So please attentive regarding this. Every year the same question has been asked in your question papers. That is annual examination, first PUC board exam. Now how to solve it? Let us first of all, it is our nothing but here x and y axis. Let us consider a unit circle here. Okay, dear students, let us consider a unit circle. Now what do you mean by unit circle here? Unit circle, it is nothing but the radius 1 unit. 1 unit means whatever the unit may be, okay, the unit ಏನು ಬೇಕಾದ್ರೆ radius of 1 unit, and with the center at the origin, and the circle center is at the origin. Let us take it as O here. And now let us take a points, okay, let us take a points on this circle here. That is the first point, let us take it as P1 here, okay, P1, that makes an angle of x, okay, that makes an angle of x with the x axis, that is nothing but our positive x axis. And here let us take one more point on this circle, that is nothing but here P2, and that P2 makes an angle of nothing but here y with P1. Okay, here this angle is nothing but here y here. And let us take one more point, okay, that is nothing but here P3, that makes an angle of x plus y, that is nothing but x plus y. We can observe that this particular angle is x. And here at last let us take the point as the P4 here, this particular point as P4. That means here P4O P1 is x here, P4O P2 is nothing but here y, okay, sorry, it is a P1O P2 is nothing but y, and at last P4O P3 it is nothing but x plus y, and here P4 okay O, and I can take it the value as, okay, here I will take it the value as minus theta, and this value I can take it as minus theta. Here P4 O P2 that is nothing but x plus y, and as well as nothing but here P4 O P3 that is nothing but our minus theta I can take, or I can take it as minus y here, minus y. So now these are all nothing but the angles here that we are defined here. Now let us write down here. We shall write down the same thing. Consider a unit circle. Consider a unit circle. First point. Now let us consider the angles. Let P1, P2, P3, P4 be the points on the circle. Points on the unit circle. Circle of radius 1 unit. One thing. Then here I will write down that is P4O P1 makes an angle of x. Okay, okay, that is P4O P1 makes an angle of x. Makes an angle of x here. P4O P1 makes an angle of x here. And one more thing, dear students, I will join these points. Which point? That is P1 P3 I will join, and I will join yours this line. That is nothing but here. Okay, P2 and P4 I will join. Okay, now let us examine. That is nothing but here P4 O P1 makes an angle of x here. Then next P1, okay, what we are having, that is a P1 or else P4 O P2, P4 O P2 makes an angle of x plus y here. And next here at last, that is nothing but here P4 O P3. Okay, what we have, P4 O P3 makes an angle of minus y, makes an angle of minus y, as well as P1 O, this is nothing but center O I am taking here. Okay, center is O. P1 O P2 makes an angle of y here. P1 O P2 makes an angle of y here. These are all the basic things that we had seen here. One thing. Now, what are the coordinates of all these things that we shall take here? Okay, I will. That implies, according to the figure, the coordinates of the point. Okay, the coordinates of P1, P2, P3, P4. Okay, P4 are, that is nothing but here P1 of, what we can write here, what is the angle x here, cos x comma cos y. What is the angle here? That is cos x and cos x only, cos x and sin here. Dear students, it is cos x and sin x. Okay. Next comes the coordinate of the P2. Now what is the coordinate of P2? The P2 coordinates are, that is cos of x plus y and sin of x plus y. That is the coordinate of nothing but here P2. Then comes our coordinate of P3. Okay, coordinates of P3, that is nothing but here cos of minus y comma sin of minus y. And at last the coordinates of P4. Okay, that is nothing but I will write here, that is P4 coordinates are, since it lies on the x axis, the value for x will be 1 and y will be 0 here. X value will be 1 and y value will be 0. Now these are nothing but what the coordinates of P1, P2, P3 and P4. Now let us examine here from the given figure. Okay, from the given data, what I can observe here is, that is nothing but here P1 O P3. Okay, P1 O P3 from given, from the data, from figure we can observe we can observe that is P1OP3 and that is P2OP4 are congruent. What it is? Are congruent. Okay. Now if it is congruent, that implies we are having here P1 P3 is equal to what it is? P2 P4. What we can write here? If it is congruent means P1 P3 is equal to P2 P4. Okay. That means P1 P3, this distance is equal to P2 P4. Now here, by making use of what it is? Distance formula. By distance formula, that is nothing but our P1 P3 square. Okay, by making use of distance formula. What is the distance formula? Distance between 2 points, that is nothing but here x1 y1, and if you are having h2 y2. Now what is the formula, distance formula? Let us take it as PQ, that is nothing but here PQ square is equal to x2 minus x1 square plus of y2 minus y1 square. That is nothing but our distance formula. Now according to that, so here what is the coordinates of P1? That is nothing but here cos, okay, what we are having cos x and sin x, coordinate, and P3 coordinate. What are the coordinates of P3? That is nothing but here cos of minus y, comma sin of minus y. Now here that is nothing but x1 y1 and x2 y2. According to the formula, what we have? x2 minus x1, that is nothing but cos of minus y, okay. Then we are having here minus x1, that is nothing but cos x whole square, plus of y2 minus y1, that is nothing but here sin of minus y, okay, minus of sin x whole square, okay. That is x2 minus x1 square plus y2 minus y1 square. Just I will simplify. Now here cos of minus theta, it is nothing but cos theta only. So what we get here? Cos y minus what we have here, that is cos x whole square, plus of minus sin y minus sin x whole square. If I take here minus sign outside and square it, again it will be positive. So what we get here is, that is cos a minus cos b. What we get here, that is cos square y, okay, plus we have cos square x minus 2 cos x cos y, or cos y into cos x. This is the first thing. Then plus here, if I take here minus sign outside and squaring and minus taking outside, that means it becomes positive. A plus b whole square it becomes. So what we get here, that is nothing but sin square y plus of sin square x, next plus 2 sin x sin y, okay. Now here what things happen here is, we know the value for cos square y plus sin square y value is 1 here, and as well as cos square x plus sin square x value will be 1 here, okay. Cos square x y and sin square y value will be 1, and cos square x plus sin square x value will be 1. So therefore what we get? 1 plus 1, next here minus 2 cos x cos y, okay, plus of 2 sin x sin y here. Now here, so why it is 1? Because cos square x plus sin square x value will be 1 here. Cos square x plus sin square value will be 1 here. Now 1 plus 1, what is the value? 2 minus 2, okay. If I take here minus sign outside, what we get is cos x cos y minus of sin x into sin y, okay. So what is the LHS part here? That is nothing but here P1 P3 square. Let us take it as equation number 1 here. Let us take it as equation number 1. By making use of distance formula, I had solved it. Similarly, P2 P4 square, P2 P4 square is equal to, I will take this is a symbol for similarly, also P2 P4, that is P2 and P4. What are the coordinates of P2? That is nothing but cos of x plus y and sin of x plus y, okay. X1 y1, it is nothing but your x1 y1, and it is nothing but our x2 y2. According to formula, x2 minus x1 whole square, that is nothing but here 1 minus of what we get here, that is cos of x plus y, okay, whole square, plus of y2 minus y1, that is nothing but here 0 minus sin of x plus y whole square. Now you square it, a minus b whole square, that is nothing but 1 square plus cos square of x plus y minus 2 cos of x plus y. a minus b whole square. Then comes our that is minus square, that is nothing but plus square only. What is the remaining part is sine square of x plus y. Here also we can observe that cos square theta plus sine square theta value will be 1 here. So what is the remaining part? 1 plus 1 minus 2 cos of x plus y, or else I can write as 2 minus 2 cos of x plus y here. Now what is the value here? That is nothing but here p2 p4 square. What you can write the reason here? Because cos square theta plus sine square theta, the value is 1. Whatever the angle may be, angle here is x plus y, x plus cos square x plus y plus sine square x plus y, that is nothing but cos square plus sine square value will be always 1, but the angle should be same here on both the side. Now here we know that what we are knowing is but p1 p3 is equal to p2 p4, that implies here p1 p3 square is equal to p2 p4 square. Okay, if I squaring down both the sides, both the value will be same. Therefore from 1 and 2, okay, I will erase that part. Okay, that is nothing but here, which implies, okay, 1 equal to 2, that implies the value of 1 equal to 2 here. If you are taking this value as a equation number 2, that implies 1 equal to 2. Okay, 1 equal to 2 becomes, so now here what we get is equation 2. What is the equation 2 here? That is the 2 minus 2 cos of x plus y equal to 2 minus 2 into cos x cos y minus of sin x sin y, minus of sin x into sin y. Now here we can observe that 2 to get eliminates, minus 2 also get eliminates, that implies here what we get is cos of x plus y that is a 2 into, which is equal to 2 into cos x cos y, okay, minus of sin x into sin y, sin x into sin y. Now at last 2 to get eliminates, okay, that is minus 2 get eliminates, that is the required result. That is nothing but cos of x plus y equal to cos x cos y minus of sin x sin y. Now here dear students, one particular thing you have to remember, that is the diagram here, and the clear very neat explanation of the diagram you should draw in your examination. You should make use of the rounder and all the geometrical instruments that are required here. Okay, very neat diagram carries of 1 marks here. Now in the examination, this particular theorem or the proof, it will be asked for 5 marks. Along with that, 1 mark simple thing will be asked. Okay, that will be asked. That is a simple example related to that. It will be asked in the examination here. Okay, dear students, it is a very important theorem that is for 6 marks. That is a 5 plus 1 or 4 plus 2. That may be asked in your annual examination. Fixed compulsory 1 question. That is question number 49A question. Okay, dear students, please pause the video to note it out.